Bearcats, this is part 2 of our review. We're continuing. I'm going to call this part 2. We're starting with 4A. We're talking about ellipses, and we've been given an equation of an ellipse, and we are to find the center, the vertices, the foci, and the eccentricity of the ellipse. Okay, so we're going to find the center, and I'm abbreviating the center, the vertices. When we have vertices, we're going to have 2 of them. That's on the major axis. Co-vertices are on the minor axis. The foci, and finally, the eccentricity. Okay. We haven't talked a lot about eccentricity this year, but you did talk about it last year. Eccentricity is E equals C over A. And it gives us an idea of how elongated or how rounded our ellipse is. How elongated or how rounded our ellipse is. The closer that number is to 1, the more rounded our graph is. It'll run between 0 and 1. So the closer it is to 0, the more rounded the ellipse. Okay, so let's take a look and let's see if we can find out this information. Okay, well the center is pretty easy. We're going to take a look at our x plus 2, our y minus 1 part, and we would know immediately that our center was at -2 and +1. Remember, again, sketch as we go so we can know. So our center is at -2, +1, so our center is about right there. Then what do we see? We see A and B squared, and we know that A is always bigger, so this is our A squared, our A squared value, so A would be 10, and that makes this our B, so B would be 9, and that's important. So A is with the Y, so it's going to be up 10 and down 10, so from where we are. So we're going to count up 10, I'm just going to say that's 10. And we're going to count down 10, so I 1, 4, 6, 8, 10. So we're count 2, 4, 6, 8, 10. Make it look similar. And that would be our major axis of our ellipse. So our vertices, think about this. If our center is at -2, 1, and we added 10 and we subtracted 10, then our vertices are pretty easy to find. They're going to be at -2. 1 plus 10 would be 11. And -2, 1 minus 10 would be at -9. And there are vertices. All right, our eccentricity is C over A. We don't know our C value yet. Our A value we do know is 10, so we do know we can put it over 10. Foci. Our foci are going to be, we're going to use, if we want to graph this, you could. Sorry, I didn't mean to switch around on you. Our B value is 9, so we go left and right 9. So 2, 4, 6, 8, 9, we'll just say it's about right there. And 2, 4, 6, 8, 9, we'll say it's about right there. And we would have an ellipse that looked, ooh, I've missed that. Sorry. Ooh, making very bad ellipses these days. All right, so we'll say it's about right there. And I will try to erase a little to make it look a little bit better. It's really hard without a grid here. So let's see if I can kind of erase a little bit of what I did here. That looks a little bit better. Not great. All right, so let's move on. And you will have to use your imagination on the picture. Okay, foci. Foci are going to be, we're going to use the equation, remember, A squared minus B squared equals C squared. We already know that A squared is 100. We know that B squared is 81, and that is equal to our C squared. So we have 100 minus 81, which I believe is 19, equals C squared. And so for C, it's the square root, positive or negative square root of 19. All right, so here's what we're going to do. Just like before, where we went up and down from the center to find the vertices, we're going to go up and down to find the foci. So our center is at -2, 1, and we would go, I'm going to erase that, and we would go up a square root of 19, and then we would go down a square root of 19. And you can write it just like that. If it doesn't come out to be a nice, pretty number, you can leave it just like that. So we're going to write it as -2, 1 plus the square root of 19, and -2, 1 minus the square root of 19. And there are your foci. All right, and we found C to be the square root of 19. So the square root of 19 over 10. And in that case, you would have your calculator, and you would go ahead and 19. That kind of did something weird on me. And that would be approximately, oops, up here, that would be approximately 0.436. So sort of in the middle. So not, real rounded, kind of a regular looking ellipse. So just a basic general ellipse that you would consider. All right, let's take a look at 4B. All right, with 4b, same thing. We want to know the center. We want to know the vertices. We want to know the foci. And we want to know the eccentricity. And again, eccentricity is C over A. And we'll approximate that in just a minute. All right, here our center is pretty obvious. We're going to be at 5, -3. Let's go ahead and know because we're going to graph as we go. So 5, 1, 2, 3, 4, 5, and negative 1, 2, 3, and there is our center. A is always the bigger number. I think this is going to be our A value, and of course that's A squared, so A is actually 6. And in this case, B is actually 1, because 1 squared would be 1. All right, so again, this is a vertical ellipse because the larger value is with Y. So from here, we're going to go up 6. So you're up 1, 2, 3, 4, 5, 6. And we'll go down 6. 1, 2, 3, 4, 5, 6. Oops. 1, 2, 3, 4, 5, 6. Yes. All right. And so that's our major axis. It's going to be a very narrow ellipse because our B value is only 1. So we would go over 1 and we would go back 1. And our ellipse is going to look, oops, something like that. All right. Now, our vertices, remember this ordered pair was at 5, -3. And we went up and down, so we changed our Y value. We went up and down, so we went up 6 and down 6. So -3 plus 6 would be 3, so that would put us at 5, 3. And -6 minus 6 was -9, so it was at 5, -9. Again, we know our value of A here is 6. We still need to find the value of C using our A squared minus B squared equals C squared. A squared is 36. B squared is 1 equals C squared. Looks like 35 equals C squared. Square root both sides. And our C value is approximately square root of 35. So our foci are going to be somewhere here and here. And so we're going to add the square root of 35, and we're going to subtract the square root of 35. So our foci are at 5, -3, plus the square root of 35, and 5, -3, minus, the square root of 35. And there you go. And C is the square root of 35. We'll put that in our little formula for eccentricity. And then we'll just put that in the calculator, and then we have the square root of 35 divided by 6. And we get approximately 0.986. Okay, because 0.986 is really close to 1, that makes us have a really elongated ellipse, an elongated ellipse. All right, let's look at 4C. All right, in this case, it is an ellipse. We know that because we have two square terms. They're added together. Our coefficients are different. If the coefficients had been the same, the 16 and the 9, if they both have been 16 or both have been 9, then we would be looking at a circle. We'd be looking at a circle. That would be the only difference between an ellipse and a circle in standard form. We need to put this in graphing form before we can actually label all of our center vertices and foci and eccentricity. To do that, we will complete the square. To complete the square in an ellipse, you'll have to complete it for the x and the y since both values are squared. The very first thing I would do is I would group my x's together and my y's together and move the constant to the right. So I would take my 16x squared and I would group it with my negative 32x. And there's a plus sign. I'd take my 9y squared and group it with my 72y. And then I'd move my 16 to the other side. The next thing I do is we need to take care of these coefficients, and we need to factor just the coefficient out to be able to complete a square. So I take the 16 on the outside, and when I have x squared minus 2x, and then you can put a blank in there. And I'd keep my plus sign. I'd take my 9 out, and I'd have my y squared minus, or sorry, plus, 8y plus my blank equals negative 16, and I'm going to have two blanks because I have two blanks over here. Now, because we factor something out, we'll have to multiply. When we put something in this blank in a minute, we would be multiplying by 16. We also would multiply by 16 over here. And if we multiply the second one, we'd multiply whatever goes in this blank by 9, then we're going to multiply by 9 over here. Don't forget to do that. That's really important. You end up often with a negative on the right, and you can't do that, so that might trigger your little careless mistake, but just be very careful. All right, we're going to keep our 16. Please don't let that go. But we're going to end up then with a binomial squared. Plus, we're going to keep our 9. Don't let that go. You're going to end up with another binomial squared, and it's going to equal something. I always like to set mine up so I kind of know what it's supposed to look like. All right, the squared has just moved to the outside, and so now I have my x. Since this is subtraction, this will be subtraction. I take half of this number, so half of 2 would be 1. And if I take 1 and I square it, I get 1. That goes in the blank on both sides. I keep my 9. I bring down my y, because it's already squared out here. I have a plus sign, so I have a plus sign. I have half of 8 is 4. And 4 squared is 16, which goes in the blank here. And, oops, and here. All right, and on the right side now, I go ahead and simplify things. And when I do, I'm going to get that to be 144. We know that all ellipses are equal to 1, so I'm going to divide 144 by 144 to get 1. I have to divide this by 144, and I have to divide this by 144. Okay, it just happens in this particular case. It doesn't happen in all cases, although it happens often, but you can't rely on that. They don't always flip-flop. But 16 goes into 144 9 times, so it becomes 1/9. So you end up with 1 at the top, which you really don't have to write. You have x minus 1 squared over 9. And over here, 9 goes into 144 16 times. So you end up with y, so 1/16. So y plus 4 squared over 16 equals 1. And now we have our ellipse, so we can graph or identify our center, our vertices, our foci, and our eccentricity. And eccentricity, remember, is c over a. All right, our center is pretty easy now to identify, which was not near so easy in the other form. Our center is going to be at 1, -4. I'm going to graph that. So at 1, -4, I'm just going to say that's 1, -4. That's my center, and I'm going to say 1, -4. That kind of helps me when I'm figuring out my ellipse. Again, the bigger number happens to be with y, so it's going to be vertical, and therefore A is 4, and in this case B is 3. So that would be able to graph it. So A is 4, so I'm going to go from here. I'm going to go up and down 4. That changes my y, so plus 4 and minus 4. So if I go up 4, I'm going to end up at the axis, and I go down 4, I'm going to end up at -8. My ellipse would go left and right 3, so I would end up with -3 this way, so I think it's going to put me like at -2, and it's going to put me over here. So my ellipse is going to look something like that. That was not very good. I'm not drawing very good today. All right, so that would be where my ellipse is. But my vertices, remember now, are up and down 4 from this center point. So the 1 stays, and I go -4, but plus 4 puts me at 0. I go -4 minus 4 puts me 1, -8. All right, so my A value we already determined was 4. I need to find my C value again by the A squared minus B squared equals C squared again. A squared is 16 minus B squared, which is 9, equals C squared. And so now we have 16 minus 9, which we know to be 7. So 7 equals C squared, or C equals the square root of 7. So again, to find our foci, which is on the major axis, you're going to go plus the square root of 7, and we're going to go minus the square root of 7. And you can write it just like that. So you have 1 plus the square root of 7. Oops, 1 -4. Ooh, missed the one, bad. Cross that out. So I'm going to go down here and write my foci. So 1 -4 plus the square root of 7, and 1 comma -4 minus the square root of 7. And there you have it. And since C is the square root of 7, we'll put that right there. And we will put that in our calculator, and you'll get the square root of 7. And you're going to divide that by 4. And when you do, you're going to get approximately 0.661. So again, kind of right in the middle kind of ellipse. All right, let's go on to 4D. We're almost done. All right. Again, the same kind of thing. We're going to complete a square before we're able to identify everything. So let's take a look at this. Let's group everything together, group our x's. So we have 4x squared and our 16x. We have a plus sign. We have 25y squared, and we have -150y. And we remove our 144 into the other side, so it's -144. Okay, again, we have these coefficients we need to factor out. So we'll take out the 4 in the front, and we will get x squared plus 4x. And now we can put our plus blank. Keep our plus sign, factor out the 25, and get y squared minus 6 y plus blank equals negative 144, and we're going to have two blanks. The first blank, remember, will be multiplied by 4. The second blank by 25. All right, let's bring down our 4. Don't let that go. And we'll end up with a binomial squared. Plus we'll bring down our 25. Don't let that go. And we'll end up with a binomial squared and equal something. All right, the square's on the outside. X comes down. Plus sign, half of 4 is 2. 2 squared is 4. That goes right there. 25 came down, y comes down. Subtraction, half of 6 is 3. 3 squared is 9. 9 goes down. All right, on the other side, let's see where we are. We have to calculate that out. All right, and when we calculate the right side, we get 100. I made a mistake and brought down 144 instead of 141. 141, be really careful. This should come out to a number that both this coefficients should divide into evenly on this test. It won't always be true, but on this test, that's what you should see. So to divide by 100 to get 1, divide by 100, and divide by 100. This becomes 1 over 25, so you end up with x plus 2 squared over 25, plus this becomes 1 over 4. You end up with y minus 3 squared over 4 equals 1. And there is our ellipse that we can now find our center, our vertices, our foci, and our eccentricity for. We're going to go ahead and graph. Our center is pretty easy. Our center would be at negative 2, 3. So at negative 2, 3. That right there. Our vertice, or our bigger number this time, is with x, and our a, so that's our a value, and a would be 5, and this time b would be 2. So it's going to go right and left. It's going to be a horizontal ellipse, 5 each way. So if this is at negative 2, 3, then you're going to be adding 5 and subtracting 5 from the x value. So negative 2 plus 5 would put me at 3, 3. And negative 2 minus 5 would give me negative 7, 3. So we'd be over here would be positive 2, 3, negative 7, 3. This is my horizontal major axis. All right, and then we would go up 2 and down 2, so up here, and eventually your ellipse is going to look something like that. So we have a horizontal ellipse. Now, finding the, those are the vertices, finding the foci. The foci, again, are going to be a squared, b squared, a squared minus b squared equals c squared. So if 25 minus 4 equals c squared, 21 equals c squared, so c equals positive or negative square root of 21. That's already prime, so we can't simplify that any. This time, instead of plus or minus 5, you're going to have plus or minus the square root of 21 for your foci. So your foci are going to change the same way your vertices always change. So we're going to have 2, which is what our original, negative 2 is our original. We're going to have negative 2 plus the square root of 2, 3, and negative 2 minus the square root of 2, 3. So that is your foci. Eccentricity, remember, is c over a. Well, c was the square root of 21 over a, which is 5, which is going to give us approximately the square root of 21 divided by 5, which is approximately 0.917. Again, an elongated, closer to 1, an elongated ellipse. All right, let's go to part 5. All right, this time we want to write the equation given just a picture, just from a picture. So we know we're going to end up with a fraction plus a fraction equals 1. We know we're going to end up with x something squared and y something squared, and we're going to end up with a or b in the bottom. So we have to think about, is the distance of 2 greater than the distance of 3/2? It is. So our major axis, I'm going to highlight our major axis, is this way. Ooh. Our major axis is this way. That means this is our a value right here, and that would be 2. So a equals 2. It's like the x-axis, so 2 squared, which is 4, would go under x. This is 1.5, so b equals 1.5. And if we square 1.5, we get 1.5 times 1.5. We get 2.25, so this would be 2.25. 2.25 for the b squared value. All right, next, and we know that's a y. The origin is our center, so it's minus 0, minus 0. That's not really going to help us, and we're really done. So we have x squared over 4 plus y squared over 2.25 equals 1. Our graph is done. All right, finally, let's look at 5b. All right, here's our ellipse picture here, and we have to think this is the center, and our center is at 2, -1. So I'm going to write that down. Center's at 2, -1. Okay, remember for our equation we have a fraction plus a fraction equal to 1. We have x something squared, y something squared. And this time it looks to me that from the center, which is at 2 to 4, is a distance of 2. And from -1 to 0 is only a distance of 1. So it looks like A is on the horizontal. So our A value is going to be 2. Our A squared value would be 4. And it looks like a horizontal ellipse. So it's going to be horizontal. It's going to go under the x-axis. So 4 is going to go right here. All right. So let's go back to our center at 2, -1. We would have x minus 2 squared, and we would have y plus 1 squared. And now we need to know b. Well, from the center to the co-vertices, the short axis, that's a distance of 1. And so b is 1, and b squared would be 1. So 1 would go right there, and voila, we would have our equation. Okay, I hope this helped you. Study hard. Make sure you work it. Make sure you've done the homework assignments. And Friday is your test, and then you can leave free and clear for the weekend for me. Make sure tomorrow on Thursday you pick up your packet on parametrics in case I don't see you or run into you next week, but it sounds like we may rearrange our schedule, so for my classes I might see you a little bit more next week than I thought. All right, have a great night. Good night, Bearcats.